Hello everyone, it's Jay, and today we'll be working through Part C on the pre-workshop module. So we're told that 210 lead is a radioactive element and that every 22 years, half of the 210 lead atoms remain unchanged, but half of the 210 atoms convert to lead 206, and we are asked what is the average lead atomic mass after 22 years. So the way lead 210 turns into lead 206 through a process known as radioactive decay. And what we know is that after every 22 years, half of our lead 210 sample is turned into lead 206. So that value is called the half-life, or T1 half. And now that we have this information, we can go back to solving the problem. All right, so we know we start with the information from Part B, so let's pull in Part B. So I've pulled in the information from Part B, and recall that Angela taught us that to solve these, we take the fraction of isotope 1 times the mass of isotope 1 plus the fraction of isotope 2 times the mass of isotope 2, and so on and so forth, and when we add it all up, we get the average value of atomic mass. So let's pull in Angela's work that she used to solve this problem. So here we have the expression to solve Part B, and we have all of our lead isotopes as well as their fractions and their masses. So let's see what changes from B to C. So we know that 22 years elapses. And in that 22 years, we know half of our 210 lead goes away and half of our 210 lead remains. So if our sample is already half 210 lead and we take a half of that half, we know that we have a quarter of our sample, or 0.25, is still 210 lead. So we can now multiply that new fraction by the same way as before. And that change is by a reduction of a quarter of the 210 lead. Now, let's look at the 206 lead. If our 210 lead is reduced by a quarter, and all of that is converted to 206 lead, then we know that our 206 lead increases by a quarter. So we add 0.25 to our original fraction, and we get the same mass. Now, we know it's only 206 lead and 210 lead that are changing, so let's add in the same information for our other isotopes to our equation. So we've added in the other isotopes information to our equation. We have all 5 isotopes, and as in Part B, we can add these up to get our final atomic mass, our final average value, which is going to be equal to 207.58 AMU. And this value should make sense. If we reduce the amount of the heavier lead 210 and increase the amount of the lighter lead 206, our average value will be closer to 206 and it will decrease. But as always, we need to make sure that our fractions add up to 1. So let's add up all of our fractions. So we have 0.3705 plus 0.1105 plus 0.262 plus 0.007 plus 0.25, and if we do that addition, we get that that equals 1.00. So all of our fractions always have to add to 1, and we know that the average atomic mass is 207.58. So let's move on to Part D. So in Part D, we have another 22 years elapsing, and we want to figure out the new average lead atomic mass. So we're going to do this very similarly. We're going to start with the information from Part C. So let's take our expression that we used in Part C, and we can copy that right down. We know this is how we must start. And let's give ourselves a little more room for this problem. All right, so we see again that another 22 years pass. So we have another reduction of a half of our 210 sample, and this time we're taking a half of a quarter, which is an eighth, or 0.125 times our mass. Now, that entailed a reduction of 0.125, so we must add 0.125 to our lead-206 fraction, and we can do that addition, multiply it by the mass, and once again, all of our other isotopes stay the exact same. So we can take those in and paste those right into our equation. And now we have all 5 of our isotopes. We can do our addition, and what we'll get is that our new mass is going to be 207.08 AMU. Once again, this makes sense. If we reduce our heavier 210 further and increase our lead-206 further, our average will go closer to 206 again, so it will decrease. And now, as always, we need to make sure our fractions add up to 1. So we can add up all of our fractions. 0.4955 plus 0.1105 plus 0.262 plus 0.007 plus 0.125, and if we do that addition, we get 1.00. So our fractions add up to 1. Our new atomic mass is 207.08 AMU. Thank you so much for watching, and I hope this video